Topic 6.3 Logarithms. The essential questions: what are logarithms and how are they evaluated? The easiest way for me to explain logarithm to you is think of what's the inverse. So let's take a look. And the vocabularies we'll be using in this section are common logarithm, base 10, implied. So here you have to notice that when we are talking about base 10, okay, so for today's lessons, I put all the base in color red. Base. When it's a base 10, we don't normally write the number 10. So think about square root. When you see the square root, you don't see the index 2. When you see 2 raised to the first power, 5 raised to the first power, the power 1, first power 1, we don't really write it down. And in the case of logarithms, if you don't see a base, this is the case where if you don't see a base, then 10 is implied. So please remember that. That's the terminology, that's the nomenclatures that we use for logarithms. When it is base 10, the reason why, because we have 10 fingers. And we do not write the base 10, the number 10. So that's something you will have to remember. When the next time you see log that represent logarithms, that means it's a base 10. Second one, logarithm. What's logarithms? As I mentioned at the very beginning of the very first slide, logarithm is the inverse of exponential functions. That's why they are being put in the same sections, same topic. Last 6.2 or 6.1, 6.2, we learned the exponential functions, which is shown here. B to the y power equals x. B to the y power equals x. So B, we call it base. When we write in the logarithm form, do you see what happened here? I put it into like a subscript next to the log, L-O-G. So when you write the base, please write it like a subscript of your English words, a small letter, a small number here. Don't ever put it in the same location, same position as log itself. So base, 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 base. And the exponent, so see what happens when you rewrite into logarithm form. Exponent is to the right hand side, to the other side of the equal sign. And the output from the exponential functions becomes the input to the logarithm function. So we call this, there's actually a name for this. This is called argument. It's not like you're arguing with someone. It's just an argument for the logarithm functions. It did not specifically mention in your textbook, but I would like you to know the terminology here so it's easier for you to understand. B stands for the base. So B, I chose the letter B. It's easier for you to remember. B is the base. It's the same as the exponential functions. Why? So exponent becomes the output of the logarithm functions. Output of the exponential functions becomes the input, which is the argument to the logarithm functions. Like we did last time, if you think you need more time to process this information, pause the videos and look at the coloring code, the color code. I put it here. Base goes with base. Exponent becomes the output for the logarithm functions. And then the output of the logarithm functions becomes the input, the argument for the logarithm functions. 3 numbers, 3 locations. Make sure you know where to put them. And again, please make sure you put the base B like a subscript to the English word L-O-G. Write it small. And the next one, logarithmic functions. Logarithmic functions. Y equals log base B of x. So how do you pronounce this? Again, it's very important for you to know how to pronounce it so that you understand. You have a fully understanding of the math sentences here. We call this as log base B of x. Log base B of x. Next one, we have natural logarithms. Do you still remember we talked about 6.2, a natural number e? In the logarithm, since we have the base e, we can put that in as a base in the logarithms, and log base e log base e. We don't really write like this. We write it natural log. Write it as ln, but next time when you see it, don't pronounce it as ln because it wouldn't stand for anything that you know. So I would strongly recommend you read it as natural log. Natural log. ln stands for natural log. So just practice reading it out. Natural log. Again, if you know the terminologies, precise readings, it'll help you understand this part. Easy. Okay? Now let's take a look. This time we have about 5 examples. Example number 1, we'll start something with very easy. 2x equals 8. So this is a linear equation you learned back in maybe math 6, math 7, or pre-algebra. How do you solve for the x? So you divide both sides by 2, then you find x to be 4. So how do you solve for x? Okay, you have to follow the inverse of PEMDAS rules. Inverse of PEMDAS rules. And that's happened with the logarithms. Did you remember I mentioned it already like 2 times? The logarithm is actually the inverse of exponentials. Inverse of exponential is logarithms. So it is the same function as exponential, but in the form of log. Log and exponentials, they go hand in hand. So let's take a look. 2 to the x power equals 8. That's exponential functions. So when you rewrite it, do you remember the base? The base. So you put it in like a subscript. Again, subscript. The output, do you see that the output 8 becomes the input to the logarithm argument? And then the exponent, so do you see the color green, becomes the output. Input becomes the output. Output becomes the input. So this is actually asking you 2 raised to what power equals 8. So that's how I like to read it. 2 raised to what power equals 8. 2 raised to what power equals 8. So look at the position of each number. 2 raised to what power equals 8. 2 raised to what power equals 8. Then you will need to know your multiplication table really well. 2 to the third power equals 8. So that's what I meant. I have many students get confused. They think that 2 to the third power equals 6. If you have that kind of calculations, make sure you double check on your multiplication tables. 2 to the third power equals 8. Okay, now let's move on to example number 2. Switching forms. Once you get the idea of switching from exponential to logarithms, can you switch it back? So the next one is, take a look, 3 to the 4th power. So in your head, you think about 3 times 3 times 3 times 3. So that's 81. Okay, again, make sure you check on your multiplication tables. 3 to the 4th power equals 81. So how do I rewrite that into logarithm forms? Again, base goes with base. So log base 3 of 81. Do you see? 81 is the output from the exponential functions. It becomes my input argument to the logarithm functions. And then the exponent is the output to the logarithm functions. Do you still remember I said log base 10? 10 is the one that you are not supposed to write the base. So in fact, if you write it like this, people will think that you haven't taken logarithm functions yet. So I would strongly recommend you just go ahead and write it as log 1000. Log 1000. But again, 10 is implied here. 10 is implied when you don't see a base. Okay? Log 1000 equals 3. And then if you think is 10 to the third power equals 1000. Of course, it has to be correct. Okay? If you are going from this way to this way is right, then definitely exponential function should be right. 10 times 10 times 10. 10 to the third power is 1000. Okay, we are visiting the natural numbers again. E to the second power equals 7.39. So you can check this out on your calculator. E to the second power equals 7.39. How do I rewrite into logarithm forms? We can definitely write it as log base e of 7.39 equals to 2. But do you remember that when it comes to natural log, when it is a base e, we don't really write it like this. We write it natural log. So you write it ln, it's actually reading it backward. Natural log, reading it backward. So last one in this example, natural log 5 equals 1.61. Natural log 5 equals 1.61. So how do I rewrite into exponential form? There's the base. Do you see that? Natural log is base e. Natural log is base e. E to the 1.61 power equals 5. E to the 1.61 power equals 5. So again, take a look at the position of each number. Base goes with base. Exponent, exponent, argument, output. Argument, output. If you need more time to process this information, pause the videos before you move on to next example. I would like you to take a closer look as I put these numbers. Base are in color red. Exponent are in color green. And then the argument or the output are in color blue. So make sure you are able to switch from one to another, from logarithms to exponentials, then from exponentials to logarithms. Make sure you practice a few so that you get a hang of it. When you are ready, come back to the videos and then move on to example number 3. Example number 3. So let's take a look at some of the properties of logarithms. Log 5 of 125. Do you still remember I said the base has to be a subscript to the log? So I'm going to remind you as much as I can, but you have to remind yourself, okay? Log base 5 of 125 equals what number? Then you're going to think about inverse. 5 raised to what power equals 125? So in your head, you should process 5 times 5 is 25. 25 times 5 is 125. So how many times did you multiply 5? Was that 3 times? 3 times. We're looking for the number you multiply 5. The number of times you multiply 5. Next one, log base 3 of 0. Log base 3 of 0. So if I think in the exponential form, 3 raised to what power equals 0? 3 raised to what power equals 0? Well, it's not possible for you to find a number you raise to a power equals 0. So there's no solution to this one. So actually no solutions. Next, we have log base 2 of 2 to the 8th power. Wow, that's a big number. Do you really have to multiply this number out 2 to the 8th power? Well, let's take a look. If we rewrite into the exponential form, 2 raised to what power? Do you see 2 raised to what power? So I put it in color green here. 2 raised to what power equals 2 to the 8th power. Is that obvious? You have the same base here, 2, 2. So the green would equal to the blue 8. Do you agree? Same base, they would have to have the same exponent in order for them to have to be the same numbers. So 2 raised to the 8th power equals 2 raised to the 8th power. So the answer to this one is 8. The answer is 8. Actually, there's a name for this one. It's called the inverse properties. We'll be more specific later on. You just have a quick overview on this one. It's called the inverse property. It's going to be very useful later on. Inverse properties. 2 and 2, they are the same base. I've seen some other teachers teaching this concept. When you see they are the same base, do you see that's the base for the log, that's the base for the exponent, and they are the same, so they basically cancel each other out, and you are left with just this number, the exponent 8. So that's another way of explaining it. If you like that, you can definitely use it. Again, if you need time to process all this information, pause the videos and then come back when you are ready. Next one, we have the calculators. So this one, you can just have your calculator ready and then type it in, see what you get. So make sure you practice this. I'll try to make a video later on to show you how to use the calculators. And I know some of you may not have a calculator, scientific calculator with you. Then you can use the decimals or the GeoGebra to help you out. So just go ahead and use your calculators and then be sure to ask any questions you might have. Log 900. So where's the base here? Do you see that? There's no base. So what does it imply? It implies a base 10. So check on your calculator. When you enter the log 900, do you get 2.95? And natural number, natural log, the same thing. Use natural log e. Natural log e equals 1. E raised to the first power equals e itself. And then as we discussed before, when you have a negative, so the argument is a negative, there's no solutions. It's not possible for you to find a number raised to a power that equals a negative number. So this should be an easy and quick check. On your calculator, you will see it's going to give you an error message. So make sure you practice that. Example number 5, solving. So how do you solve? Remember, when you calculate, you follow the PEMDAS rules. And then PEMDAS, I mentioned this several times already, exponential and logarithms are the same thing. Even though they have different format, they are the same thing. So when you calculate, you follow the exponent. Logarithm is exponent. Exponent is logarithms. They are the same order of operations. So PEMDAS, parenthesis, exponent. So that means logarithms is following the parentheses and it has a higher order than the multiplication and divisions. So when you solve, what's the order? What's the rules you have to follow? You're going in the inverse order, the going backwards. So that means you have to deal with addition, subtraction first, followed by multiplication, divisions, then exponential, exponent and logarithms. The last one would be parentheses. Okay, so when you solve, make sure you go backwards. So let's take a look at example first here. 25 equals 10 raised to the x minus 1 power. 25 equals 10 to the x minus 1 power. I don't know what number, 10 raised to what power equals to 2.225. So what do? I try to take the logarithms on both sides. Do you see that? Log base 10 of 25 equals log base 10 of 10 to the x1 power. So think about the very last example that I show you in example number 3. Do you see this one? When you take the logarithm base 10. So as you write here, base 10 of 10 to the x1 power, I am just left with the exponent. Now, you can use your calculator to find out what is log base 10 of 25, which turns into 1.4. So this part you can use your calculator. And then equals x minus 1. So I'm assuming you can deal with this very last step. This is just a basic linear equation. Add 1 to both sides, so you find x equal to 2.4. You definitely want to plug this into your calculator. See if 10 raised to the 2.4 minus 1 power equals 25. It's going to be very close, but since it's a calculating, there's going to be some kind of truncatings. You can check that yourself. Next example, natural log of 2x plus 3. Natural log of 2x plus 3 equals 4. So how do I deal with that? So I am rewriting. This is logarithm form. I cannot deal with this. I don't know what to do with it. So I rewrite. I don't see a base. Since it's a natural log, I know it's going to be base e. Base e. E to the 4th power equals 2x plus 3. So this is asking you to rewrite into the exponential form. And then you can use your calculator to figure out what's e raised to the 4th power, which is 54.6 equals 2x plus 3. So again, this turns into a linear equation. So I'm going to subtract 3 to both sides, which is 51.6 equals to 2x. Divide both sides by 2 to find the x value equals 25.8. That's the end of our lesson. Again, if you have any questions about these logarithm functions, from my experience, many students get stuck on this concept, the inverse, going backwards. Make sure you practice a few of the questions writing from exponentials into logarithms, and then rewrite logarithms back into exponentials to help yourself get a better understanding of the concept of rewriting from logarithms to exponentials to logarithms. It's going to be helpful for you to learn things this way. As always, if you have any questions, make sure you send me an email and then I'll try to get back to you as soon as I read it. And then you can start working on your homework assignment.